Okay, hello. Now we are going to create a mid surface. So the first thing we're going to do is to create a new file. We name it like mid surface. We click OK. Now for instance of my license, I can create a mid surface here in MSC Patron. So the thing I'm going to do is to import another file that is already with a mid surface. So I click import and go to the file folder that I have saved and it's in. Okay, click apply and click OK. Here's an ISO view of my element, and now I'm going to associate the edges with my face. So I go to geometry, associate, curve, and method surface. I now check auto execute for reasons of mistakes. And here I'm going to associate this curve with this surface and click apply. Now I'm going to do the same with the remaining edges. And change the surface. Okay, made a little mistake right here. So here, please. I select this right here and surface all the face. Okay, looks like a little mistake right there. Right there. Mention my surface. Click apply. Okay. I do it again until I get it right. Okay, now it's associated. Okay. Okay, now all my edges and faces are associated. associated. So the next thing I'm going to do is to paper mesh all the mirror faces surface, and I click on this view here, and I go right here, go to meshing, create mesh surface. In element shape squad, I'm going to change the measure to paper and quad 4. In surface list is my entire model, and value I'm going to put 9. Okay, now I apply and I have my model array mesh. So right now I'm going to do an equivalence. So I go to equivalence to verify element boundaries, and I'm going to check the free edge. Right now, none of my elements at geometry boundaries are connected. They have free edge, but this will be reminded with the equivalence comment. Now, the way I'm going to resolve this problem is going to equivalence all and object all and method tolerance cube. I'm going to click I'm going to click apply, and here now I go to again to verify element boundaries and click apply, and everything is connected, and all my free edge are shown are desired free edge. I'm going to create a total load, so I'm going to create total object total load and type element uniform. The name of total load. We need to make sure that 2D is under target element type, and input data in the part of surface load. Oh, sorry, the edge load. We click 0, 100, and 0 forward. For X, Y, and Z. Now we click OK. Now we are going to add the loads and constraints. We go to select application region. And we choose geometry right here. And in select surface, we're going to click the edge of any small hole on the end of the junction box and the greatest y coordinate. First of all, we we need to select the edge icon. So we're gonna have to look for it, and here is our little holes that are right here. We select surface, we click to the edge and go to add. Now we add now right here, and for last but not least we add this. Now we're going to do the same for the little circles of the other face. And we click OK and apply. And here are all my forces in there. And this is how it should look. Now I'm going to control the base of the junction box. So I go to loads. I'm going to create a displacement and type nodal. Click fix, and in input data I'm going to put in translation 0, 0 and 0 are all 0 in rotations too, and click OK. Now I select the application region, and in select geometry entries I'm going to click on the curve on each icon. There is this. Okay, and select geometry entries. I'm going to select these little holes that are in the base. So I select it, click add, select add, and add. So I click OK. Now I can click apply. So my base is now fixed. And now I'm going to create isotropic material for my box. So I go to properties, isotropic, create object isotropic, and method manual input. So I go to material name, aluminum, and input properties, elastic modules of D10 is 6, a Poisson error of 0.3. No, OK, and apply. Okay, it seems we made a mistake. Okay, here is 10 is 6. Now the material is already created, so we are going to add the element properties. Now we go to solid, create 2D shell, and we our name will be 2D shell. We go to input properties and material property name. We click aluminum. Okay, before of this, we need to make sure that homogeneous and standard formulations are selected. No, we can do this as we already did. We click OK. But in thickness, we're going to put the thickness of thickness is going to be 0.125 and click OK. And for select application radius, and we're going to select all of our model. We click add, OK, and apply. Now we're going to check the load cases. So we go here and click modify. We select default for existing load case. We made sure everything is alright. The displayment is here, the total load is here, and click cancel. Now the next thing we're going to do is to run the analysis. So we go check this analysis deck in translation parameters. We click small, OK. Solution type, we make sure it's linear static, OK, and click apply. Now go to MC mastering and search for our PDF. Okay, open and run. Okay, now we go to pattern again and check the results. Okay, we click apply. Now our results are attacked. And we're going to look for the deformation that is created. We go to results and action create deformation. We select the file A1 static and it select deformation result. We select displacement translational and click apply. Here's how should look our model. Now we're going to remove the different plots and erase the geometry to get a better illustration of the load effects. We click on display attributes and remove the check for show undeformed box and from the tutorial as well. We click apply and now go to click on the plot erase icon and under geometry we click erase. Okay. Now we're going to look the von Mises stress. So we go to create, fringe, and we select stress tensor and continue. Here using quantity has to be von Mises. We click apply. Now I'm going to modify the attributes to get a better display fringe path. So I go to this. So in display, I click element edge and check the tile ball, the two tile balls, and click apply. And here's how it looks. So this is all for my part. Thank you for watching and see you later.